In the earlier video, we introduced the divide and conquer approach to binary search. The binary search uses only half the division, as the other half is discarded. In this video, we demonstrate the true divide and conquer strategy, with the merge sort. The merge sort divides a list of items in half. Each half is divided subsequently, until only single items remain. When two items remain, they are merged in order. Then the next two sets are merged in order. And so on until a single set remains. Given a list, the first index is 0. The last index is length -1. The middle index is the average of the first and last indices. We can divide the list into two halves, like this. The left half gets a new last index. The right half gets a new first index. Then we can use recursion to calculate the middle of each half and divide them further. Repeat the process and eventually, the first and last indices will meet. Then we stop the recursion and retrace our steps. Each time we return from the recursion, we merge the two halves. And we end with a single list of sorted items. Here's the pseudocode for the recursive division. This section calculates the middle, makes recursive function calls, and then merges two halves. And this is the base condition that ends the recursion. All these are encapsulated in a function. Let us now look at the merge process. Here's a source list of 3 items. The first item is the left half. The second and third items are the right half. On the left half, there is only one item. So the low index and the low last index point to the same item. On the right half, the high index points to the first item. And the high last index points to the last item. Finally, here's a temporary list. It's the same size as the source list. The items in the source list will be copied here, in order. The temp index points to the first available position. Now we're all set to begin the merge process. First we compare the items, to which the low index and the high index point. The smaller of the two is copied to the temp list. And the temp index advances to the next available position. The high index advances also. Once again we compare the items, to which the low index and the high index point. The smaller of the two is copied to the temp list. And the temp index advances to the next available position. The low index advances also. Now the low index has passed the low last index. This means we're done with the left half. The remaining items in the right half are copied to the temp list. We're done when the high index passes the high last index. Finally, the sorted items in the temp list are copied back to the source list. Here's the pseudocode for the merge process. The while loop compares the items in the left half and the right half, copies the smaller item to the temp list, then advances the indices. The loop runs until all items in either half have been copied. This loop runs when all the items in the right half have been copied. And this loop runs when all the items in the left half have been copied. Finally, the sorted items in the temp list are copied back to the source list. Here's the implementation for the merge sort. The function accepts 3 inputs. The source list, the low index for the left half, the high index for the right half. And here's the code for the base case and the recursion. And here's the implementation for the merge function. The function accepts 4 inputs. The source list, low index and low last index for the left half, high last index for the right half. And these are the local variables. The rest of the merge code is straightforward.